Hello to everyone. My name is Adibuddin Ahmed, working as a Assistant Professor Department of Electrical Engineering in Institute of Engineering and Technology, Lucknow. So we are discussing a very important subject, that is power system protection. This is a lecture 2 of power system protection. In previous lecture, we discussed about the introduction of the power system, what are the power system scheme, and the need of power system protection, the syllabus and the course outcome of the power system protection. And after that, we discuss about the component of the power system protection. So the component of the power system protection, we have 3 component. So first component of the main component of the power system protection, that is circuit breaker, we already discussed. Now in this lecture 2, we will discuss about the second component, that is the transducer. So the transducer, basically it is serve as a sensor to detect abnormal condition or the transform to high values of short circuit current and voltage to the lower values. So basically transducer is a device that is used to sense the signal, sense the physical quantity, and this physical quantity may be the voltage and the current. So we are going to sense this physical quantity, and the main sensors that is used, that is current transformer and the potential transformer. These are very two fundamental equipment that is used for the sensing, and these are the transducer in the power system protection. So the current transformer designed for the to provide the standard continuous current at 5 ampere. So sorry, this current transformer is provide the standard secondary current of 5 ampere. So we provide, for example, primary current having a some fault section, faulty current. So for example, if there is a fault, so if there is a fault, for example, so primary current may be 1000 ampere, but secondary current is fixed on 5 ampere. So this is a work for the CTT, that is the current transformer. So the current transformer having some standard available, that is 50 by 5, 100 by 5, 150 by 5, 200 by 5, 250 by 5, and 300 by 5, 400 by 5, 500 by 5, 600 by 5, and so on. What is the meaning of that 800 by 5? 800 by 5 rating CT doesn't mean, but that only refers that when the primary current, a faulty current will be 800. When faulty current will be 800, the secondary current will be 5 ampere. So that is very normal phenomena or normal ratios. What about the 1000 by 5? That is means the primary current will be 1000 ampere. So the secondary current will be 5 ampere. So for example, if we take this type of CT and primary current will be 500, half of the 1000. So what will be the secondary current? Obvious, same, that is 2.5 ampere, because the ratio of the transformation is same. So this is all about the current transformer, and during the faulty condition, the short circuit current could reach 10 times the normal for the short period and time without damaging the CT winding. So CT is very important, and when there is a fault, the faulty current is 10 times, or you can say the 12 times, 15 times higher than the normal short circuit current or normal current. But this current is transient currents, and this current is for the some short time period. Now the current transformer has a primary winding that usually consists of one turn and secondary winding of the several turns. So the current transformer has primary winding that has consist of the one turn and secondary having a different type of turn. That is why in power system, or you can say that is why the substations, you can see the current transformer having a some bar type structure. So what is a bar? Bar is primary of this current type transformer, and secondary having some turn. That is why you are not going to see the secondary, but the bar, the basically you can say this such type of bar and such type of structure is there. So, this bar having some input and having some output. So, this bar is covered by the CT. So, this is the primary winding of the current transformer, and also the unsafe, it is unsafe opening the secondary of the current CT whose primary is energized. That is safety procedure. We are not going to open the secondary when, or you can say that we are not open the secondary when primary is energized. Secondary is always closed because of the safety parameters. Now, talking about the potential transformer. So, potential transformer designed to operate the constant standard. Secondary voltage of potential transformer is 120 volt. For low voltage application, the potential transformer just like another 2 winding transformer. So, potential transformer is just like a 2 winding transformer, but potential transformer having some different type of structures, because the primary voltage in the high voltage or extra high voltage levels, a capacitor voltage divider circuit is used for the PT. Somehow we can say this all unit is capacitive potential transformer, CVT, or capacitor voltage transformer, that is CVT. We can say the CVT, capacitive voltage transformer. This is basically a capacitor potential transformer. And the primary voltage is impressed across the series connected capacitors, and the potential transformer is used to measure the voltage of the few kilowatts across the capacitor of the smaller capacitance value. So, we are going to measure the high voltage with the help of some capacitive features of the capacitor. That is why that is called the CVT. CVT is generally used in power system protections. So, if talking about the third important element of the power system protection, that is protective relays. Protective relays is very important because protective relays is a sensing element, and after the sensation, this protective relays will give signal to the another circuit, and this circuit is used for some primary defense, just like that blowing the alarm or some indication, and after that this signal will refer to the circuit breaker, and circuit breaker will detach or will remove the faulty section from the healthy section. So, a protective relay is a device that processes a signal provided by the transducer, and which may be in the form of current, voltage, or combination of these two. So, current transformer basically gives the current, and potential transformer will gives the voltage. So, in relay we are going to use the current or voltage or the combination of the current and voltage coming from the CT and the PT both. These signals arise as results of faulted conditions such as short circuit, defective equipment, and lightning strikes or surges. So, when there is a fault, so that is why after the fault the rating of the voltage and current will disturb. So, that this disturbance will sensed by the protective relays, and after that the corrective measure or protection action will taken by the relay. So, protective relay can initiate or permit the opening of the various interrupting devices such as alarm, and after that the relay will give a signal to the another relay. This relay is called the auxiliary relay. Actually, we have some two type of relay. One is relay, normal relay, and another is called aux relay, auxiliary relay. So, this first relay is used to indication purpose or used to alarming purpose, and another relay, that is auxiliary relay, that is used for the interruption of the circuit breaker. So, rather than considering the two, we generalize, or we in general way we can say this is a relay, but relay having some two part, one is normal relay, one is another auxiliary relay. The electromechanical relay develops an electromagnetic force or torque from the signal provided by the transducer. This force or torque is used to physically open or close a set of contacts. This set of contacts, that is spring based contacts or some switches, to permit or initiate the tripping circuit of the breaker to actuate the alarm. So, we have some tripping mechanism, level of tripping. In later on we will discuss what are the level of the tripping. So, different type of switches are there. So, the solid state or static relays, we have some classification. One is electromechanical relays and another is solid state relays. Also, we have some further classification of the relays, that is pneumatic or digital relays. So, solid state or static relays is energized by the same signal as in an electromechanical relay. However, there is no physical opening or closing the relay contacts, because in solid state relays no physical contact is there. The switching is done with the help of some power electronic switches. Just like that, we can take an example of this BJT. You can understand that is a BJT, emitter, collector and base. So, this is BJT working as a switch. BJT will work as a switch when we will give the signal to the base of that BJT. This BJT will behave like a shorting emitter and collector. So, this also work as a switch. This also work as a switch, passing the signal from the emitter to the collector. So, this also working as a basic switch. That is why, but rather than we have some electromechanical switches, we have some this type of switches. So, this is a basic switches, we can say that. So, electromechanical relays, they predate the solid state relays. Electromechanical relays basically the previous generation of the solid state relays, or you can say the first generation is electromechanical relay, then after the generation is upgraded in terms of solid state relays, or you can say this is a solid state relay. A majority of the power system using the electromechanical relay, because this is the first generation, the improved reliability, versatility and the faster response in the solid state relays have made for the more attractive nature. So, these qualities incorporated in the new generation, that is called the solid state relays. And some electromechanical relays have been replaced by solid state relays, and newer installations are mixture of the both. So, we have some different type of industries has very large scale. We can not exactly remove one type of relay from the industry, because industry having some continuity. That is why we are going to replace the older version, that is the electromechanical version, with the newer version of the solid state version, step by step, because solid state having some varieties, because there is a no moving part, there is a no wear tear in the solid state relays, and there is a no noise, and the size of overall of the solid state relay is very compact. That is why we are going to replace the solid state relays with the solid state relays in place. So, electromechanical relays is replaced by the solid state relays. Now, our next topic that we will discuss about, that is function of protective relays. So, basically what are the function of protective relays? These are the responsibilities, or you can say the fundamental duties of the protective relays. The purpose of the protective relay system is to isolate only the faulty component of the power system. The basic purpose or fundamental duty is that relay or relaying scheme is a fundamental duty to detach or to separate the faulty section from the fundamental section. That line is very important in the power system. You heard many times that detachment or isolation the healthy section from the faulty section. So, the relaying equipment are classified into groups. First, you can say the primary relaying equipment, and another is called the relay backup or backup relaying equipment. Primary relaying equipment, first line of defense for protecting the equipment, and backup relaying equipment is the secondary line of defense when primary fails. So, we have two lines of equipment, first line of defense and second line of defense. So, we have two type of relay. First relay is used for the fundamental action, and after that when fundamental action failed, then second line of defense came into picture, and that will protect our power system. Protective relays works on the sensing device. It sense the faults, then know its position, and finally it gives the tripping command to the circuit breaker to trip the circuit. The circuit breakers, after taking the command from the protective relay, disconnect the faulty element. As you know, by clearing the fault fast with the help of fast acting protective relay associated with circuit breaker, the damage of apparatus is reduced. So, if we are going to use a fast acting circuit breaker, this is a fast acting protective relaying. Fast acting protecting relaying means we are going to use the fast protective scheme. When we are going to fast protective scheme, this protective scheme will give the signal to the circuit breaker in the very short period of time, so that the spreading of the fault or the damage of the fault is minimized. For example, in any area there is a fault, and the faulty current having some magnitude of 10,000 ampere, this very high current. If this current will persist in the system for 2 seconds, surely it will damage all the equipment, including your TV or refrigerator or some other equipment, if this fault is transformed into the distribution part. Also, this high current can be damage the transformer, the isolator, the bus bar. So, that this current is having some high value. That is why we are going to eliminate, we are going to reduce. For example, if the time duration is limited by 0.2 second, so we can say that this 0.2 second 10 times lower the 2 seconds. So, this time period is still okay for the equipment. If 10,000 ampere will flow for 0.2 second, the transformer can understand or can bear this current, but it is not capable, transformer is not capable to bear the 2 second current, the high amount of current for 2 seconds. So, that is very important. If we are going to reduce the timing of the protective relaying, we can save our equipment, or we can reduce the risk for damage. So, that is very important. This is basic the structure of a relay working block diagram. We have some current transformer, voltage transformer and relay setting. So, we have relay setting, current transformer and potential transformer. From the current transformer, we can take current, from the voltage transformer we can take voltage, and we have some relay setting also. After that, relay internal information processing, that is calculation. So, we have some comparators in this type, in these sections. These comparators will compare the value of current and the value of voltage with the some threshold value, and this threshold value will indicate the safety value. For example, we can say that if current in this section exceed 5 ampere, so we can understand this is faulty condition. If the current is below the 5 ampere, so we can say this is a okay or healthy condition. So, we are going to compare this current. Now, we have some relay outputs, trip signal and some another circuits. So, this is a relay output, and relay output is some relay mechanism, some tripping mechanism is there, and relay will give the signal to the some another systems and some circuit breaker. So, with the help of this circuit breaker, we will disconnect the faulty section from the healthy section. So, this is basically basic block diagram of the relay. Now, but the continuity of the supply maintained, that is very important, that the continuity of the supply is always maintained through remaining healthy section. By clearing the fault fast arising time is reduced, and therefore, the system can be restored to the normal state sooner. So, that is very important, that how close or how fast we can detach or we can separate our faulty section from the healthy section. That is why. Now, after that, the transiting state stability limit of the system is greatly improved. So, because the system is going to prone or system is going to affect some transient condition. That is why we called the transient ability of the system, transient stability of the system. So, transient stability limit of the system greatly improved, permanent damage of the equipment is avoided, because high value of current for higher time will damage the equipment or development, and most simple faults such as single phase to ground fault. This fault, because if you are not removing this fault or you are not removing the faulty section from the healthy section, so this single line to ground fault may be possible convert into a line to line fault or 3 line to ground fault. So, this is very important. Now, we can understand the basic relaying procedure through this figure. This is basically a basic or fundamental circuit diagram to understand how relay will works. We have some bus bar, this is a bus bar, and this bus bar having circuit breaker. Circuit breaker is responsible to connect or disconnect. We have some continuous bus bar. In this bus bar we have some CT, that is a current transformer. So, the secondary of this current transformer is here, primary is here and secondary is here. So, the secondary of this current transformer is connected with this electromechanical switch, that is called the trip contact of relay, that is electromechanical switch. Also, we have some tripping circuit. This is the tripping circuit. We have different type of DC battery system. In the substations, you can easily say or easily observe the battery room, that is battery room. So, in this battery room we have different type of batteries, we have stock of batteries. So, that produce very high voltage, very high DC voltage, that is used for the trimming of the circuit breaker, that is why. So, also we have some tripping coil, and this tripping coil is responsible to trip the circuit breaker. So, this is the tripping coil of the circuit breaker, you can say. So, first what will be happen, suppose this lines is working in healthy condition and there is a fault at that point. At point F there is a fault. You can understand that some trees is fall upon the line or some line failure or some fall will some line is breaking, and after that this line touch to the ground. So, that high amount of faulty current will flow through this line, that is the faulty section or fault. So, after that condition, in this condition high amount of current will flow through this line in this section. This current will sensed by the circuit breaker, and the CT secondary will gives the same rated current according to its ratio. Suppose that primary having some 10,000 ampere current, fault current, and secondary having some 5 ampere, and CT having ratio 10,000 by 5. So, secondary will CT will gives the 5 ampere secondary current, and this secondary current will flow through this electromechanical coil, and this electromechanical coil is sufficient that when 5 ampere current will flow through this will operate. When less than 5 ampere current flow, this coil will not operate. So, because 5 ampere current will flow, because this coil will understand that 5 ampere current flowing condition is a faulty condition. So, that this coil will energize, and after the energization of this coil, this section is closed. This section is closed. So, why this section is closed? So, after the closing of this section, what will be happen? This whole circuit, this is the trip coil circuit, will active, will energize, and after the energization of the trip circuit coil, what will be happen? After the energization, the trip coil will energize, and after the energization of trip coil, the circuit breaker will operate. So, this is some common phenomena that after when faults occur, the 5 ampere current will flow through the CT secondary, and because of the 5 ampere current of the CT secondary, this electromechanical switch will operate. After the operation of this electromechanical switch, the whole circuit will OK, and after that the whole circuit is closed. After that the trip coil is energized, and after the energization of the trip coil, the circuit breaker will operate, and this faulty section isolate from the healthy section. So, all the faulty section isolated from the healthy section. So, that is very important. So, this is a basically phenomena of the protection to understand how the relay. So, this part, what is this part? This part is the relay part, and this part you can say the circuit breaker part. This part is the relay part. This is the relay part, and this part is the circuit breaker part. So, we have some relay part and circuit breaker part. So, with the help of this we can understand what are the working of the relay, how the relay will work, and with the help of some sensing element, and sensing element always have some threshold. With the help of some threshold we can raise or we can compare the value. One point is important, the minimum value of physical quantity. For example, the minimum value of current, if you are talking about the current, the minimum value of current that can capable to operate a relay, that can capable to operate this coil, that is called the pickup value. The minimum value of current that can capable to operate this coil, or on that value the relay will work or the relay will energize its contact, it is called the threshold value, or you can say the pickup value of the relay. Hope you enjoy this lecture. Thank you so much.